Welcome to the Cowboy Up Podcast, where talk is all about the West. This episode is brought to you by White Stallion Ranch and produced by Cowboy Spirit Radio Network. We all know the power of DNA. Well, horses have DNA too. Christa Lafayette, founder and CEO of Etalon Equine Genetics, joins Russell and Alan to talk about the fascinating role genetics is playing in equine health, training, and breeding.
Well, Alan, one of the greatest parts of being a dude rancher, besides getting to live here, is all these amazing, interesting guests that find their way to the little dude ranch outside Tucson. And Christa Lafayette, we learned, has her own podcast. And so while she's on vacation, I sucked her into our podcast. And here she is, and we're going to talk about her really groundbreaking company.
Well, I'm so thrilled to have her here. I can't even express it. But the bad thing is she knows so much that I could sit right here for 5 days and not get 5% of what she knows. So,
well, I'll go get a cot, some food.
Yeah, I think we need that.
We have a bathroom around the corner. We'll be all right.
We gotta narrow our search down because it's so broad right now that I don't know anybody that could be broad enough to accept everything that's out there.
Right.
So.
Well, Christa's company, as I mentioned, is Etalon Equine Genetics. She has her own podcast because this is such a broad, big subject, genetics unbridled. Christa, can you kind of give us an outline of what you do, what your company is all about?
With pleasure. Thank you for having me. And not just on the podcast. This experience at this ranch is spectacular.
Oh, thank you.
I mean, I can't even say I brought my husband. It was his idea. He's from New York. And you got him on a horse, smiling, wearing a cowboy hat and sunglasses on purpose. He's so excited. So thank you so much for that.
That's what we do, or at least try to every day.
It's spectacular. I think if more people came out here, the hook would be even deeper set than mine.
Well, thanks.
So thank you. So yeah, we specialize in equine genetics at our company. We are horse people, but we're also pretty nerdy. And we all tend to have horses. We love them. Other animals as well, cows and dogs and all these ranch stock and pleasure animals, companion animals. And we realized that the field of genetics is this magical zone that is growing every day. Every day it's faster. Every day it's more precise. Every day there's something new to discover. And we realized that in working with our horses and our horse people, we have this unique situation. Horses have already been genetically testing in the different groups for 20, 30 years for parentage and then for a small number of diseases and a couple of traits. So the horse people are uniquely positioned. They understand genetics already for 20, 30 years if nobody else does. Your average dog person, no idea beyond maybe a breed test. But if we start a laboratory and we handle the deep science, and we test all these animals, and we turn around and we ask the experts about the animals, the horse people, that is a road to accelerated discovery. And that's what we've done. And we've made it fast and accurate, and we've made it affordable because we don't want to exclude anyone. We want everybody to come in, put their knowledge in, their 2 cents, and let's see what all we can discover.
Okay, so let me give you 4 traits. There's 400, but let me give you 4 that you can tell me, yeah, we could take some horses and put the various components together and give you a 3-legged horse or whatever. I'm not sure that's your goal. Could you do something like that? I mean, if you have a customer come in off the street and design a horse,
we can.
And basically turn that over to you, you can.
Well, we can. So there are ways to do that. The simplest way is using an application we put together called Build a Horse. And what it does is it takes all of the genetic rules that we know about, color and health, speed, height, gait, temperament, all of these things. And it rolls them all into an algorithm such that you can describe the horse you want in the app. Like I showed you earlier, the buckskin with the blue eyes, it's fast 0 to 60, not gated. And you can click build and it will find the animals that you need to combine to create what you want. It's an easy button for breeding. Or if you're too late in the breeding season or you didn't save enough money for the stud, not that horse people ever do that. There is a Find a Horse app. Again,
Really?
Describe what you want, click find, and it will find you a pre-owned model.
Well, you probably couldn't take all 30 traits or 50 traits or whatever you're asking, and you couldn't get them in any given horse, could you? You just would have to take the largest number that was available of the trait that you're looking for.
I mean, I think it depends on your list. Some people are color crazy, for example. They got to have, a Tobiano Dung Splash with 1 copy of Leopard Complex Spotting. And okay, that exists. We actually have contests with our clients where they have multiple color genes. It's ridiculous. And it's a contest. It's a thing they want to do, right? They enjoy it. And I think that same thing you can extrapolate other traits that you want. Maybe you want a taller horse. Maybe you want a horse that is downhill or uphill. Maybe you want a horse that is fast or slow or endurant or gated. All of those things exist. I haven't personally tried every combination in Build a Horse. I think that's a pretty big number. But I would imagine you'd get pretty far with your wish list because there are a lot of horses with a lot of different traits.
So if you want to test your horse, your horse in your stable, what do you do?
Oh, it's really hard. You have to go online and create a free account, and then you have to order a test. The tests are usually packaged in large bundles for very inexpensive prices, like 70 to 80 traits for about $150. Then you print your form, you go out into the barn, you whisper sweet nothings in his ear and pull out some tail hair. Then you casually walk away as you bundle it in the envelope and send it in to us. Then we'll extract the DNA and provide the results to you online.
How much tail hair do you need?
We usually say like 40 to 50 hairs, about the size of your pinky. If you're pulling mane, you wrap a comb and you pull it, it's not very much. As long as the roots are good on there, we can do it. And
it's about the roots? Is it about the roots?
Mm-hmm. Yep.
So you got to pull them. You can't be cutting them.
Yeah. Do you do the testing there at your facility?
We do. We have partners around. We're in biotech heaven or hell or whichever one you want to call it. So we have partners strategically placed around us such that if something goes wrong with our laboratory, we have plan C, D, and F. But inside of the laboratory itself, we have plan A, B, and C. So we've got backups on top of our backups, different platforms and technologies, and we use what we need to get it done accurately and fast. And it changes all the time because the field of genetics is unbelievably growing and changing every day.
Yeah. Interesting. Give me an example of a weird request that somebody said, I want to breed a 3-legged horse or something. I mean, pick something that nobody else would.
A weird request.
Yeah.
We've had a couple of requests where people wanted us to genetically edit their horse to make it a pocket pony.
Huh.
And by that I mean like a chihuahua that fits in your purse.
So they wanted you to do what you don't do, which is alter the actual genetics and create a little bitty horse.
That would require a ton of genetic editing. In concept, you probably could do it. Genetic editing is a thing, and it's not as complicated as most people think. The hard part with the horse is not really the genetic editing per se, but getting the embryo to take in that gosh darn mare. It's really hard to settle mares. So if you do a math model, let's say you start with 100 oocytes. Those are your
request list.
Yeah, yes, you've got 100 eggs, right? You start with 100 horse eggs, and you get them fertilized, and you create an embryo, or you make the change before or after you create the embryo. Then, when you're doing gene editing, less than 5% of those are going to take from those 100. Now you got to turn around and implant them in the mares, and less than 30% of those are going to take in good hands. So the math tells you that it's pretty hard to do one edit. It's going to be very difficult to do many edits. There is a company out there doing something like that, but they're doing it for de-extinction. They're making the woolly mammoth. Have you heard of Colossal Biosciences?
I've heard of the effort, not the name of the company. That they're trying to bring back a mammoth, and they're filling in the genetic missing pieces with elephants.
With Asian elephants, that's right. It's not really a clone of a woolly mammoth. It's woolly mammoth-like, using the traits. But it takes a long time to do and a lot of science, and you have to brute force it. They kind of have a lot bigger lab than we have and a lot more people, so they can do that. But it's a thing. It's real.
Do you deal with a lot of just people off the street that have heard that you do genetic swapping or changing or modifying or whatever?
Well, she doesn't do that.
She doesn't do it, but yeah.
Testing.
Testing. Okay.
She's not making pocket ponies yet.
Not yet.
Well, but by excluding this 80% here because they don't, you kind of do it in reverse.
Well, you are modifying. So to your point, people have been genetically modifying animals for a very long time. Purpose breeding, like it or not, is a GMO animal, right? So what we would like to do is we're striving to understand the genetics of these animals. Let's say you want a reiner and you want a cutter. My job is to figure out what is in a reiner that's different than what's in a cutter. And then what are the things that we did that was bad that we need to fix? Breeding in PSSM, a disease. Breeding in HYPP, also a disease, right? If we can modify that in your embryo and make your line that beautiful, spectacular performance horse without PSSM, that's what we want to do.
And what is PSSM?
Polysaccharide storage myopathy, causes tie-up. If you have an animal that is being fed a lot of sugar and being stressed out, you're going to see tie-up.
And so that makes that horse genetically predisposed to tying up, or they're just going to tie up?
It's a genetic predisposition. You see an animal that's got 2 copies of PSSM and you feed them high sugar and you stress them out, they will tie up.
But if you're mindful, you can mitigate that genetic disorder.
That's exactly right. If you know the animal has that genetic disorder, you can feed it the correct things and keep it on the right exercise regimen to prevent that.
Yeah.
Yes.
So a weird what if. The Germans during World War II, in their prison camps, they bred whole populations of mean dogs and German Shepherd dogs. They were trained to be killers, and to guard the camps. And basically most of them, when the Allies came and the Germans all ran off and said, here, you take whatever's left, they had to kill most of them because they had the genes so strongly in them, they weren't retrainable or trainable otherwise. And
purpose bred.
Purpose bred.
Is what you're talking about.
And what you're hitting on there is partially temperament. Temperament, we have found, we've done a couple of discovery studies with this. There's one on there called curiosity and vigilance. Certainly, the genetics influence your temperament heavily. Are they everything? No. But they certainly can make a pretty big difference. In these horses that we've been studying, when you genetically test your horse, you're going to get a temperament result. And it's going to say curious type, vigilant type, or the middle, curious, vigilant. And by asking the horse people, what we have found by and large, we cannot control for the way your horses were raised or trained or any accidents or anything, but the curious horse tends to be novelty seeking, all up in your business, kind of equally friendly. You know that horse, like, I'm all over the place, that must be for me. The vigilant horse is like, I don't think so. I don't need you, and I need my rules, and I need to be put in that stall, and I need to be fed, and you need to go away. But the interesting thing is, if you look at the curiosity vigilance horse, they are largely described as clever by their owners. They're curious enough, but also focused enough. And they're also described as passive aggressive. So if they like you, you're their person, anything you want. Hand the reins to him, You might get shouldered across the room just to see what you're going to do. The vigilant horse, on the other hand, is described to as aloof to aggressive, especially in thoroughbreds. Did anybody see the Kentucky Derby a couple of years ago where the winner crossed the finish line and then attempted to eat the lead pony?
No.
That's vigilance. And that animal probably has very few friends, probably selects one person or maybe less, probably lunges out of its stall and bites. But when it gets in its zone, I am going to win if I cross that line on 3 legs. I'm winning. And when he won and the pony said, all right, I'm going to take you to the winner's circle. I don't think so.
Really?
And that same gene works in dogs and in humans. In dogs, it's aggression, and in humans, it's thrill-seeking.
On that, we'll take a break.
Hi, Russ and Alan. This is Stuart Rosebrook calling in from Prescott, Arizona. I hope you all are having a beautiful sunny day down there at Tucson and the White Stallion Ranch. Spring has arrived here in the mountains, and we are really enjoying it. We are grateful for all the snow and rain we received this winter, but glad to see the sunshine and looking forward to hitting the road soon to enjoy our beautiful state of Arizona. We've got a great issue coming up here in the May-June 2024 issue of True West Magazine. We have features by Art Burton on bass reeves, finally getting his due. It's a major feature, and anybody who has ever read about bass reeves or has watched the current television series produced by Taylor Sheridan, they'll want to pick up this issue. Art Burton has written a wonderful feature, and Art is considered the world's expert on bass reeves, who may be the most decorated and most accomplished Deputy U.S. Marshal in our U.S. Marshals history here in the United States. We have a great feature on Edward S. Curtis by Larry Len Peterson, who's probably one of the top Western art historians in the American West, and he has just published a beautiful coffee table book on Edward Curtis, and we have a great excerpt in there on Curtis and his research into the Battle of Little Bighorn. We also have a wonderful contribution from Linda Sanchez, who's a longtime contributor and contributing editor to True West Magazine, called The Last Hurrah, the final mission of the Apache Scouts in the Mexican Revolution. Most people think about the Apache Scouts during the Chiricahua Indian Wars and how they served under General Crook and General Miles, but the Apache Scouts continued to serve the U.S. Army well into the 20th century, and this is a really good feature about the Apache Scouts helping General Jack Pershing on his search for Pancho Villa after the Revolutionaries' raid on Columbus, New Mexico. It's also a really useful travel feature that I wrote for this issue called Discover the West, and it's a feature on traveling the scenic roads of the West to through 12 different Western states, where to stay, where to eat, and how to enjoy a heritage tour while immersing yourself in one of our communities, Western communities across the United States. I think our readers will find it a really interesting feature and one that you can use to help plan your summer travel in 2024. Well, that's all we got for this month. It's going to be a great issue. If you're interested in purchasing it, check it out at truewestmagazine.com and subscribe today, or look for it at your local favorite bookstore or grocery store. Russ and Alan, thanks again, and I look forward to sharing more news about True West Magazine next month on the Cowboy Up podcast.
So, Christa, we were talking earlier, just kind of brief introduction. I wanted to understand what you did, and it was so amazing. Biotech was your background. You were heading off to medical school. You were there, and then you got literally lured away and just almost never allowed to go back to medical school. So you entered biotech and you created several companies. Biotech's a big term to me. Is it a big term? Is it broad encompassing? And
Yeah, I mean, I
what
guess.
part was yours?
My personal area of expertise is around surgical and behavioral models in animals for translation into humans. And so what that means is every time somebody comes up with a new drug discovery or a medical device, something to help you with diabetes, something to help you walk better, whatever it is, the mandate is that you have to test it in animals before it can be tested in humans. And what I did for a living was design those models in a way that refined, so we used the least amount of animals, the correct animal, and in doing the least harm we could possibly do. Because you have a responsibility not to treat animals or in a cruel way or mistreat them or do anything more that's been repetitive or useless, right? And I enjoyed my job because I enjoyed discovery and I love animals. But every time I did something in the lab, I thought, I really wish there was a way we could make these discoveries without having animals live in a laboratory. And if you think about the way horses are uniquely kept in little boxes, side by side, day in and day out, they're fed the same things by the same people, then their movements and behaviors are scored in an arena by multiple judges. This is exactly what we do in the pre-medical world when we do animal testing. They're kept in little boxes, they're fed and taken care of by the same people, then their movements and behaviors are scored in an arena. And why then can't we take the samples we're already using from horses for DNA and use that information that's out there and talk to the experts, the people who know the horses, and discover stuff a lot faster at a much cheaper rate? And we do, and it works.
And I mean, I've been on your website now. You gave me a little tour. I mean, it's extensive, it's impressive, it's interactive, it's all those things. There's investment here. That didn't just happen.
There's my blood and the blood of a lot of people in this company, and all of us are obsessed with animals, particularly horses. And I am proud to say we took it to a stage where we did get investment from some spectacular backers, whom I can't thank enough. They're not only invested in the company monetarily, but they're actually truly excited and supportive of this. And nothing feels as good as it does when you can call and text some of these big name investors and say, look what we did today. And they're like, oh my God, send me pictures. It's unbelievable. The excitement around the love of horses and the discovery of science, it's tangible and it's real.
And some of those same individuals we're talking about, do they have desire to have their own horse that has a handful of these, or are they satisfied with breeding the characteristics into a group of horses?
They may have their own interests. Let's just say we test all their horses and give them feedback on all of them, and then they move accordingly. So you can profile horses. You can say, this quarter horse is probably going to be better at Western Pleasure, and this quarter horse is probably going to be a better cutter. This temperament will probably go with this trainer, and this temperament might be better at 4-H. You can actually do that, and we do it. And not only for the top trainers, because let's say Andrea Papani, whom I love to watch ride, or Corey Cushing, their top horse, I can't ride. I'm not that good. My top horse will run around all day and not kill me, but may not perform to the level of their top horse. So let's say I'm training with Corey Cushing. He may be winning on this one horse, but his livelihood is around making his clients happy. If I'm his client and he finds me a horse that makes me really look good and makes me happy, he wins. I win. The horse wins.
But it wouldn't be his top horse that he special trained for years. It would be a horse with some different characteristics that make it easier for you to ride. Is that?
Well, I would argue
maybe?
that the horse is far more trainable than I am.
Okay.
So probably he's better at getting me a horse that fits me than trying to train me up to his good horse.
Okay, well, that makes some sense.
So you're the founder, but there's some other pretty credentialed folks here
Yes.
involved.
Yes, there's some really spectacular people. There are some great minds. One of them is Dr. Samantha Brooks. She's one of the top equine geneticists in the country. And she's just, I mean, can I say badass on this show?
Absolutely.
She's a badass. She's an eventing writer. She's a brainiac. If I ask her a question, she goes into these math models and starts spewing out stuff. I have no idea what she's talking about, but it works.
And then she can go out and get on her horse and
Yes.
put on a show.
I like to say I've seen her break zip ties with her bare hands.
Wow.
She's
Well,
amazing.
you know, a lot of people have fancy horses, but they themselves can't ride them, and
She
can't
can ride
do
'em.
it all. She can do it all.
Yeah, she's maybe 105 pounds soaking wet with 2 bricks in her pocket. I have seen her send a draft horse spinning and running for the hills. She's amazing.
Yeah.
She's so much bigger than her frame actually
Yeah.
shows. And the other founder of this company was Dr. Carlos Bustamante. We were talking earlier, your wife did some wisdom testing. He was responsible for making that work.
Oh, that's right.
Dog
Yeah,
test.
the dog DNA wisdom panel.
Yep,
yeah, and Dr. Bustamante.
Yep, Carlos
That-
Bustamante.
that's
Yep.
his.
And I love him. He's a ball. He's a blast. He's super smart. He's funny. Carlos, if you're listening, I love you, but I think I love your wife more. She throws great parties.
Well, I hope they're listening.
They might. And he is involved in human population genetics. And one of his big causes right now is showing that human genetics has a huge flaw. Does anyone know what it is?
Overpopulation.
No. Almost. It's actually the opposite. Human genetics is white. It was developed in primarily white European Americans because those are the people who could afford the tests and who are around medical school to do it. So it only represents the time. You're not seeing the whole picture. So you're not seeing any of these other health or abilities or diseases or anything in the rest of the world's population.
Well, Hitler would be happy. That's what he was breeding for.
So no kidding.
Yeah.
That's fascinating.
Yeah.
So, sort of redirecting, you talked about a horse with a blaze, and the horse was from France, and it was tested.
Oh, yes. Yeah.
So
So you're talking about the bridge from horses to humans. Okay. So here's an example of how this works for discovery.
In a good way.
In a good way. We had a woman send in a sample from France of a horse, and we ran it, and we came back to her and we said, you've got a chestnut filly or a mare. We can tell she's female. We can't tell how old. And she's fast 0 to 60, and she's negative for the 6-panel quarter horse diseases, and otherwise good. And she came back and said, that's great. Why is she deaf? And I said, well, I don't know. So we looked at the profile photo, and inside the profile photo, we saw that the mare had a bald face, that's a white face, with distinct cobalt blue eyes. And we noticed that all of her siblings in the database had the same features and were reported to be deaf or hearing impaired quite a bit. So we looked at the genetics, and we found in this region called MITF, there was a big chunk missing. It's called a deletion. It's where a chunk of your genetic code just kind of disappeared. We're not sure why, but it did. And what that genetic code did was it told melanocytes, your color-making cells, where to go in your body during embryonic development. So if you have a map that tells your color-developing cells where to go, and the map stops, that's where the melanocytes also stop. And you don't get any color. So you get these areas of depigmentation, white, blue eyes, that kind of thing. But you also have a problem inside the middle ear, because if you don't have melanocytes settle inside your middle ear, inside the cochlea, you can't then have cilia cells, which are what allow you to hear. So we found the reason the mare was deaf because of this unique genetic deletion. We got all excited. We got together and got our paper ready to write, and we took this mutation and we threw it against the human genome, and we found that the same kind of disorder exists in humans for the same reasons, and it's called Waardenburg syndrome, type 2. And what's crazy about this is these people have pale skin on the face, cobalt blue eyes, often a shock of white hair, similar to the blaze in the horse, and cobalt blue eyes, and they're also deaf. The magic behind that is to find that defect or that disorder or that issue in that human took about $3.5 million and about 7 years. And it took us 3 weeks, $600.
Wow.
And it was awesome.
Well, what did you do with it then? Can you add that gene and then people will pick up hearing? And
So that experiment has been done in mice. They
Okay.
have mice who are all white and they are deaf from birth. And they did a type of gene editing through
Yeah.
inoculation. And those mice were reported to begin to hear at the age of 3 months. My question is, did they get color later? If you let them mature, did the melanocytes migrate anywhere else? Was it targeted? I believe it was targeted in the inner ear, so they just repopulated there. But I wonder what would happen if you did it, if you rewrote the whole genetic code to have that deletion removed and put back to normal. Would they get color?
interesting
I
question.
don't know. Be fun to see.
That's just spooky that you play with. I'm not telling you that it's bad, but it just is where you could go with that is just like hard to even imagine. where
Nothing
all you
ever
could go
comes
with
without a downside.
it. Yeah.
So we're horse guys. You're a horse person.
Yep.
We're all in the horse business in some way. If somebody comes to you with a purebred quarter horse, no appendix, you look back 6 generations, you're not going to see any thoroughbred. It's according to their paperwork, their pedigree, what are they going to show up? What is their ancestry going to look like?
So Ancestry will compare the horse's genetic makeup to a reference population around the world. So there are reference populations around the world. For instance, horses out of Middle Europe, heavy-set, large-boned, hairy horses, those are known as drafts to us, right? We call that European heavy horse. Draft horses, while they're all a little bit different, Percherons and Shires and whatnot are a little bit different, they overlap so severely that we can't call them individual breeds by genetics. You're going to see a little bit of that in your quarter horse. Thoroughbreds the same. Most thoroughbreds to date are so inbred because it's a closed stud book. Their genetic signature is very, very, very distinct, and you are going to see some of that signature in your quarter horses because way back when somebody was a thoroughbred and contributed that genetic overlap. It doesn't mean if you see their horse says 50% thoroughbred genetic makeup in your quarter horse, it doesn't mean their father or mother was a quarter horse. A thoroughbred. It means at some point that genetic content was contributed, and that's what's been passed down to your quarter horse. Then you'll see, in your average reining horse, somewhere between 36 to 40% overlap with thoroughbreds, probably 20% draft, 5-10% Arabian, depending on the line, a little bit of Iberian, a little Spanish blood. It depends on the bloodline and, believe it or not, the discipline. The disciplines definitely separate out, and the average value for one purebred quarter horse is completely different than it is for another by discipline, which makes sense.
Meaning a racing quarter horse compared to a cutting quarter horse, those lines, there's going to be visible genetic difference. So here's a weird question. I tell, and you can correct me, obviously you're an expert and I'm not, I'm an observer. So I used to ride a cutting horse for a long time. I was never a cutting competitor. I love riding cutting horses. I love to see them work. I think it's just one of the most amazing things of all the amazing things horses do. And, I like anybody who pays attention. I've seen these yearling, 2-year-old cutting horse bloodline horses that have never been ridden, never had any human interaction on their back, cutting cattle. So cutting as a competition is a blip in time. Like it's like a millisecond in the history of horses. How does that get into their genetics? That quickly. We get evolution, right? If we're a believer, we believe it, right?
Yeah.
But how does it get there so quickly?
You're talking about the legend of the Cowie gene. We are looking at that. I suspect it's probably not going to be one thing. It's probably going to be a combination of a couple things. Think about, again, dogs. I have 2 dogs in my life right now that are near to each other. One passed away and the other one's new. One was a Great Dane, and this one's a Belgian Shepherd. If I'm going to go out and herd sheep, Am I going to get very far with my Great Dane? Probably not unless there's a couch out there somewhere. Now, if I need someone to hold my couch down, the Great Dane's your dog. I mean, it's just absolutely not going anywhere. But definitely the Belgian is bred to do this work and pays attention to hers and can't stand it when the family disperses. She's got to have everybody in their nice little bunch. Those animals, even in generations, 7, 8 generations back, somebody somewhere was good at that, and that's the one they picked to continue to breed. And maybe it was a combination of genes, maybe it was a new mutation that made them good at it, like gaited horses. There's one gait gene that allows horses to have the ambling, smooth gait that they have. That's known, but there are at least 4 more that we suspect are out there. Somebody somewhere recognized a trait in an animal that they saw being passed down, and they hyperbred that, and it became a thing.
Well, is it true to say that, I don't even know how to word this, but here's a horse with all these genes, and let's say it's this part of this paper. And the cutting horse gene's pretty small, and it's up here in the corner. And then you have all these other things. Is it safe to say that there's probably some of the offspring with this little piece of DNA that just going to get left behind, just not
get it?
That's not going to be strong enough to even show up on testing in a few more generations? So
it depends, right? So genetics, at its very simplest level, is down to if I'm looking at your genetic code, you remember Jurassic Park, right? And they've got the ACTG, those are your base pairs.
Yeah.
Those are the individual pieces of code in your DNA. One change in a letter is enough to alter you depending on where it is. In fact, PSSM is one change in one base pair, and it causes a very serious outcome. Conversely, some other aspects like lordosis, that incredible swayback you see on the North American saddlebred, we know there are 4 different regions involved in that, 4 different base pair sets. And so if the animal has 1, it shouldn't have it. If it has 2, it shouldn't have it. If it has 3, it shouldn't have it. If it has 4, 85% chance it's got it. So some genes are simple, and some genes are very complicated and interplay with many, many others. So we don't know the answers yet. All we can do is say, okay, we got these 2 families of horses. This is a good cutter, this is a good cutter. These 3 siblings, this one's good, these 2 are terrible. What's the difference between these horses?
So is it going to, we'll flip on the other side of that, but is it going to come to reality where you have a prize Angus bull, and when you look at the map that he has, everything in there's bad, or 80% of it's bad? Are you going to be able to say, this one should go to the killer pen, and because he's got too many of the bad traits?
So it depends, and I say that, I know you hate that answer, but the reality of it is, how many times have you heard the story of 2 so-so horses breeding a spectacular racehorse?
Yeah, well, you hear that for sure.
How many people do you know who themselves are unbelievably successful and bright, and their kid is an idiot? Or conversely, their kid's genius, and they're like, how did this happen? Right?
Yeah.
It's not one parent or the other parent. It is what you get from each parent that combines to make you. And that's what people don't understand. People say, you only need this stallion or you only need this bull. That's just not how that works.
Got to be a third. There got to be a third part in there, because otherwise all the twins would be just the same. And where do you get the variation then?
Yes. So that's all about inbreeding. So people don't understand. Inbreeding can be controlled by looking at individual sets of genomes that are inherited. In other words, if it were true that your mother and your father passed exactly the same sets of genes on to you as they did to your brother and your sister, you guys would be essentially triplets. Are you the same as your siblings? Thank God, right?
So how many sets of not alike genes do they have so that there's some that'll take the family in a different direction?
It is random. Every time you are producing an offspring, you're getting 50% from one parent, 50% from another, but you don't get the same 50%, which is why 2 siblings can have completely different inbreeding coefficients. One can be 8%, the other can be 3%.
You're not being very encouraging here for me. So it's hard. I mean, you think of it from one side and you think, my God, we can, make a smarter herd of people out there, by working with it. But you think on the other side and think, wow, there's enough bad ones, and they're still floating around out there. Nobody's trying to change that. And, there's a offshoot of some people that kind of have not a good outlook on life.
So let's just say, for the record, I don't do people.
Yeah,
like
but
animals.
You do everything but, so I'm not going to accept that, because I got to think that 80% of your conclusions would go over.
Those things do
you
apply.
Can't get out from under the heavy rock that way.
But with people, of course, comes ethical and cultural challenge,
Yeah.
I'm guessing.
And people don't want to believe the truth often. If the truth
Yeah.
doesn't suit whatever
That's
their
a pretty-
perfect picture is, they won't accept it.
Uncomfortably true. That's a true statement about a lot of aspects. So we're running out of time, and that's too bad, because this was great. And so Christa Lafayette, Etalon, Equine Genetics, is that the name of the website? Where do they go to get their site?
Yep. If they Google Etalon Equine Genetics or Etalon DX for diagnostics or horse DNA, you'll find us.
And Genetics Unbridled is the podcast. And, I see this just a natural next step, is you're talking also about taking the same approach very obviously to the cattle business, which actually, what were we talking about? Horses are luxury items for the most part, and not for every application, but a lot of times. Cattle are not very often luxury items. Yeah. They're an important part of agriculture and an important part of the food supply. And if this approach is applied there, it can make it better.
Absolutely. It's all about sustainability and suitability. Farming is a hard business, and the people, unfortunately, making decisions about what happens in the farming world are living in big cities and don't know where eggs come from. And so we need to do everything we can to make these tools right at our fingertips to make the process smoother, better, and more successful. More of the cattle need to live without getting respiratory illness. More of them need to produce better on lesser hardy feeds, because there's more and more people, and as the temperature heats up and climate becomes less amenable, we need to adjust, and we have to do it fast. It's really important.
Well, Alan raised Barzona and you shifted when you took over. So that was a different set of genetics than, what was it, Hereford prior to that?
My dad was so proud of his polled Hereford cattle, and he never could see that they're not very good cattle for desert, for scrubby desert. But they were pretty because they were pretty, and they had a good reputation. People would say, "Oh,
that was the dominant breed, wasn't it, out here?"
Those are the good breeds, and they were a good breed in a lot of circumstances.
In England, right?
Yeah, in Hereford, England.
In Hereford, England.
But they weren't good for Arizona desert, and bless his heart, I never could get him to agree to that.
But he liked that last pen of steers. But we are over time. Yeah. So Etalon, Equine Genetics, go find out about your horse. Here at White Stallion Ranch, we say girls and horses, they're just a match. And we see it every day. In fact, I think if it weren't for the females' love for horses, I'm not sure dude ranching would still be thriving. It just is a trend we keep on seeing. Women coming together to enjoy the dude ranch, and horses being that central experience. They come without their husbands if they have them, or they're just coming together, and they enjoy the variety of activities, but also feeling safe and comfortable, and just not having to worry about much. Rooms, meals, activities, and of course all that horseback riding is the central experience that brings them all together. www.whitestallion.com is where you find out a lot more, the whole website, And if you'd rather talk to somebody, we have great people answering the phone at 888-977-2624 or whitestallion.com. Well, and that was super interesting, and it's a great example of where science and advancement in science can be applied in a positive manner that can do good.
It's not all that often that we get the situation where what you just said is true, but it certainly is true about where we're going with genetics and splitting genes and taking characteristics and breeding them in a breeding program. It just made my mouth water to see where we potentially can go with that.
Yeah, and when it gets into the cattle side of agriculture, it's going to help.
And that's a wrap from the White Stallion Dude Ranch in Arizona. All you horse owners, check out Etalon Equine Genetics at etalondx.com. That's ETALONDX.com. A thank you to Stan Husted's production team. For updates, news, and some great horse photos, follow us on Instagram and Facebook. Next week, talk turns to Western history and emigrant tales of the Platte River raids with guest Janelle Maloney. Until we meet again, this is Lynn Weezy Sneed, reminding you to sit tall, ride safe, and enjoy this week's song, Dreaming of Paris, co-written by Walter Salas, Cynthia Keefe, and Brenda Hunt, while rafting on the Green River in Utah.
Wild horses coming off the ridge, looking for water and a place to rest. But they really just want to go to Paris. Flock of geese coming down the river, looking for a place to spend the winter. But they really just want to go to Paris. Paris, oh Paris, don't ever stop dreaming of Paris. Paris, oh Paris, the water at the bottom of the well, the sound in the middle of the bell. Don't ever stop dreaming of Paris. Rider in the writer's room, the next chapter, the next tune. They really just want to go to Paris. Artists in the studio, what colors will they choose? Mona Lisa is their muse. They're gonna find her in Paris. Paris, oh Paris, don't ever stop dreaming of Paris. Paris, oh Paris, the water at the bottom of the well, the sound in the middle of the bell. Don't ever stop dreaming.